Yeah? Sort of, kind of? All right, so a 10-foot ladder leans against the side of a building with its base 4 meters from the wall. Okay, so really we know you don't have to actually draw the pictures like of the wall and the ladder. You can draw a right angle triangle, but you need to know what's going on. So are walls straight up and down? Do they lay flat on the ground? Are they angled, right? Because we know in a right angle triangle, we're going to have a vertical line, we're going to have a horizontal line, and we're going to have a slanted line, right? Like in a right angle triangle, we're going to have that. So the 10-foot ladder, so we have a 10-foot ladder. Is that going to be in this triangle? Is that going to be the slanted, the vertical, or the horizontal? Slanted, because it's leaning up against the wall, right? So, or the side of a building. So this is one side of the triangle. This is the second side of the triangle. And then we have the ground as well. So that's going to be the third side of the triangle. Okay, so I'm just going to go ahead and draw the picture. You don't need to put a picture together, but I would always encourage you to do so because it does get a little bit confusing if you don't. Jacob? And you can have your calculator for the whole thing. Okay, so we said that this is going to be the wall of the building. We've got a 10-foot ladder that leans up against it. And that's going to go along the ground. I drew the ladder just so that you guys would recognize where we're putting that. So now we're going to put that information on it. So the ladder's how long? The ladder's how long? 10 feet. So my hypotenuse is 10 feet. It leans up against, with its base, so the ladder's base is 4 feet from the wall. So is that my vertical or my horizontal? Horizontal, because this is the base, right? That's the base of the ladder, and it's the base that's 4 meters, or 4 feet, sorry, away from the wall. So this is 4 feet right there. So you kind of have to dissect what the question's asking, and you know it's always going to be on a right angle. So we know that we have the vertical, horizontal, and then the slanted side. Okay, so what angle does the ladder, to the nearest degree, make with the ground? So ladder, ground. So I'm looking for, from the ladder to the ground, I'm looking for that angle. If I was looking for the ladder in the building, the ladder touches the building at the top. So I'd be looking for that one. But this is the ladder and the ground. Okay, so now I've got my triangle. I've got some information. I know what I have to find. What's the next step? Thoughts, feelings? Rahat?
56.42?
Nope, that's not what I asked.
Oh, cos B, we're going to do cos?
Nope. So that wasn't the next step. You're a step ahead. So what's the next step? What do I have to do before I can pick my trig formula? I got to find my sides. What sides am I dealing with? So I'm looking at my 10-foot. Maybe putting the right angle in here might be helpful. The right angle is where the horizontal meets the vertical. So is the 10-foot side, is that my hypotenuse, my opposite, or my adjacent? It's your hypotenuse, yep. And maybe you guys don't feel confident enough to say it, but I hope that as you're sitting there, you are confident enough to say it in your head or write it down on the page. The 4-foot, is that my opposite or my adjacent? It is my adjacent. All right, Rahat, if I have my adjacent and my hypotenuse, what trig formula am I using? Cosine. I'm using cosine. So cos of the angle, and I'm using the variable theta. Sorry, that's a really light blue. That's not the best. So cos of theta. so theta represents an angle, is equal to the adjacent side over the hypotenuse. So again, if you haven't memorized your formulas, it's always good to write them down because that's kind of like muscle memory. You will remember it. So cos theta is equal to 4 over 10. Because I put the adjacent side at the numerator and the 10 in the denominator. And now when I'm solving an angle, what do I have to do in my calculator? That's when I do that second function button, right? Okay, Dion. Not only are you playing the game, you've got Jonah totally enthralled. So that cos -1 means I need to use my my second function button or my shift function, whatever your calculator is. In mine, it's the second function. Mine says second function. So I'm going to go second function cos and 4 divided by 10, and I'm going to close my brackets. Hit enter. Ooh, I should have checked to see if my calculator is in degrees. This one, it says right on the screen I'm in degrees, so that's good. So my angle, and what am I rounding to, ladies and gentlemen? Nearest degree. So what does that mean? That means a whole number. So my angle is going to be 66, and I need the symbol for degrees. 66 degrees. All right. Everybody good with that? Okay. Yeah, perhaps? Okay. All right. So this is just one more step. So we just keep building on our skills. So now you got to draw the picture. So this one's a little bit different because it's not something, a searchlight beam. So the searchlight, that's going to be on the ground, and it shines vertically on a cloud. So what's vertically? It's straight up and down, right? So you've got the cloud. You've got your little light here, and it's directly vertically on a cloud. My cloud, I don't know, my cloud looks a little sketchy. A horizontal distance of 250 meters from the searchlight. Okay, so horizontal of 250 meters from the searchlight. The angle between the ground and the line of sight to the cloud. So that would be like as if you were here and you're looking up at the cloud. So this one's a little bit different. The language is a little bit weird. And it says from the ground to that line of sight is 75. So using words like horizontal, vertical, you need to know where those go. And it wants to know, determine the height of the cloud. So am I finding the slanted line or am I finding the vertical? I'm finding the vertical. Okay, so now that I have the pretty picture, what's my next step? Find the sides. So what sides do I have? The 250 represents the adjacent side, and the question mark is the opposite. So what trig formula am I using that has opposite and adjacent in it? Tangent. So tan theta is equal to opposite over adjacent. Is the red pen okay? Can you guys see that okay? Yeah. Okay. Cos is adjacent over hypotenuse. You're missing sine. Sine is opposite over hypotenuse. Jeez Louise. Okay, so I'm going to fill in the information that I know. Tan of the angle, which was 75, is equal to the opposite side, which I don't know. Maybe I'll give it a letter. Am I going to use O?
No.
How come?
Because it doesn't make sense.
Okay. I probably wouldn't use O. The only reason why I would say that is because it looks like a 0, and that can get a little bit confusing. So we're going to use X. I like that. And then the 250 on the bottom. Yes, Rahat?
It's okay if you use CL. Because I put like.
Oh, you put like this is the cloud.
Cloud, and then that is the light.
That is the light. Okay, yeah, for sure. That's perfect. Okay, all right. All right, so we want to get x by itself. What's happening here? What math is happening here? Divide by 250. So what's the opposite to that? Times by 250. If I times this by 250, I have to times this side by 250. What happens to those 250s? What's 250 divided by 250? It's 1. We just say they cancel each other out, but really it has a value of 1. And then in my calculator, I'm just going to do, now I don't use the second function button because I already have the angle. Tan is 75, I got to close my brackets, and then I'm going to times that by 250. And we're rounding to the nearest meter, so what does that mean? What does that mean, Rahat?
That means that we're going to round to the nearest meter.
Thanks, bud.
Which means that we'll have no absolutely zero decimal.
Rahat, that's good, bud. We're good. We get the explanation. We're very smart people in this room. All of us. So I'm going to round to the nearest whole meter. Is it in meters? Yes, it's in meters. This one's in meters. Jeez Louise. So we are 933 meters high for the height of that cloud. Okay. Am I good to flip the page? No, I'm not good to flip the page. You guys good?
Yeah, I'm good.
You good? We're just going to ignore Chelsea's no? Okay. All right, so we're going to get into angle of elevation and angle of depression a little bit later on. That's going to be on Monday. We're going to do that. But I'm giving you a preview. Angle of elevation is the angle looking up from the horizontal. Okay? Another name for that, ooh, these are overlapping. This should be over here. The other name for that is angle of inclination. So angle of inclination, angle of elevation, those are the same thing. So it's looking up from the horizontal. Here's the horizontal, and this would be the angle as you look up to the plane. And so sometimes we interchange those words, inclination and elevation, just so you're familiar with that, and that just is the angle looking up. Okay. And we're going to go a little bit more in depth on that on Monday because we're going to deal with angles of depression as well. And if an angle of elevation is looking up, what do you think an angle of elevation is? Looking down. Pretty straightforward. What? Oh, sorry. I apologize. Okay, a water bomber is flying at an altitude of 5,000 feet. So altitude, just so you know, this is a vertical measurement. Okay, I'm about to draw a plane, everybody. It's not going to be pretty. Okay, that's my plane. As good as it gets. So where does it have an altitude from? Where are we measuring the altitude from? Where does it start? Where's an altitude of 0? You're sitting on the ground, right? So we know that we have some ground here, and we know that this has an altitude of 5,000 feet. Okay, the plane's radar shows that it is 8,000 feet from the target site. We'll say that this is the target site. And it's 8,000 feet from it. What is the angle of elevation of the plane measured from the target site to the nearest degree? So we're measuring from the target site to the plane. And that's kind of wonky, but we'll go with it. So angle of elevation is the angle that looks up from the horizontal. So here's the horizontal, and we're looking up. So the angle of elevation is right there. So that's your angle of elevation. Okay, so I'm gonna hit pause. You guys are gonna do the math to find this one. Since we have the picture together, you guys should be pretty confident. And we're rounding to the nearest whole degree. So first thing we're gonna do, what sides? You're gonna label the sides that we're dealing with. Thanks, bud. I'm still recording the video, it doesn't pause, I've just frozen the screen. And I don't think it pauses during the video. But it's not gonna be that way. Well, no, because what do we know about this graph? We know that none of these values can exist because we can't square root negative y. Yeah.
Can I just like,
Yeah.
can I just run with that?
Yeah, for sure. Yeah.
Hey, Miss Gallion.
Hey, Rahat.
The other day, my neighbor who was like in grade 8, he begged me to come over and help him with his math homework because everybody knows that I'm like good with math.
Okay.
And he, like one of his questions for like a man is trying to build a gym bag with tissue paper.
Okay.
So like, I knew the guys in math comments were crazy because like, who builds a gym bag with tissue paper?
I don't know.
So, Ms. Khan, I got a question.
Sure.
Does the answer start with a 3?
It does.
Okay, but,
Is it second?
It doesn't end with a 3.
yeah, I know.
Okay. It's 2 digits.
Yeah.
Is it second?
Yes, Steve? You want the answer?
Yeah.
Okay. Can I show you the
No,
answer?
don't show the answer.
Show the answer.
No, please, please, please. I really want to try to get stuff on it.
Okay, let's wait for
Don't say my name. Don't say my name.
Okay.
Let's wait for Dion to figure it out. I mean, Jonah.
Okay. We're gonna try to be nice to each
I'm
other.
not even talking to him. I'm interacting.
I appreciate
Who
that.
got
Jonah.
it, Miss Gallion?
How do you know your answer's right?
Because we have the same answer,
Huh?
and I haven't made a mistake in the last long while.
Long while. I like that. Long while.
Yeah.
Pardon? Let's see it. I need to see this plane. I need to see this plane.
I think it's really good.
I don't doubt that. Oh, I like it.
My plane
Yours
looks
is like a double decker. It's a little bit.
Sausage.
Yep, I like it.
My plane looks
Good
like
job.
a fork. I don't know how.
Okay, Jonah, am I good?
Maybe.
Can I show the answer?
No. Yeah.
Yeah?
Yeah.
Okay, this is what I got. And you guys all use tan, right?
Yeah.
Yes. Yes is the correct answer. Yes. Yes. All right. So get off the game and maybe.
I'm skipping my song.
No, you were not. You were not.
I
It was
was.
a long look
I
at
was.
the song. Okay, guys, you have.
Arun is really smart.
You guys, no question Arun's smart.
I'm listening to Kid Cudi.
You guys have 10 questions to do. We have plenty of time in class for you to finish them today. I would encourage you to start and finish this assignment today. And then you can check your pictures with me. You know, like if you're uncertain if you want to go forward, you can draw your pictures and we can check those together.